Hey folks, welcome back. This will be our last session before lunch. I'm introducing Christian Wentz, the founder and CEO of Gradient, and he'll be talking about the end state of authentication. Feel free to ask questions in the app, and then afterwards, feel free to come up to the microphone. Thanks, Christian. Take it away.
Thank you. All right, so you'll notice the title of the talk that was just announced is not the title in the agenda. I woke up this morning deciding that this is more interesting. So, new slides. But really, wouldn't it be interesting to talk about, instead of Passkeys for enterprise, which, cool, we'll kind of implicitly get there, really what we're trying to do is figure out what does the end state of authentication look like? How would we realize the ideal technology solution such that we could engineer trust into every communication? So whether it's with a consumer-facing app, enterprise authentication of users and devices, AIs, embedded systems, IoT, you name it. All of these things fundamentally have the same problem around. We need to be able to rigorously verify the identity of the device, verify the authenticity of the device, which we would say is really about the integrity of that thing. So can I trust it? To what degree can I trust it might be interesting. So we'll get into that. So first about my background, some context, and give you, why I have my perspective. I'm a chip designer by training, so did neuromorphic chip signal design at MIT. So neuromorphic is sort of like a mixture of analog and digital signal processing to achieve optimal performance. Really cool stuff. Really not done in industry anymore because deep submicron digital wins every time. Worked on a couple of companies. Gradient is my third. First in identity authentication, cybersecurity, whatever you call it. Sort of most relevant before Gradient, I spent about a decade building brain implants, neural interfaces. And you might wonder, how do you get from that to here? So we were really working on how do you establish really high bandwidth communication to the brain. Wouldn't it be cool if we could pull sufficient information out of the brain, number of channels of recording information out of the brain to understand what brain state looks like in normal and disease states. So it turns out we've actually been doing brain implants for decades for things like Parkinson's and so forth. They're very rudimentary devices. If we had many, many, many orders of magnitude more data, we might be able to know something about how the brain works and have insights into how to treat disease. So you could imagine if you come to the FDA and you say, well, I'm going to have this class 3 life-sustaining active implantable device. I'm going to stick it in someone's brain, and I'm going to connect it to Amazon Web Services. And I'm going to have a streaming continuous communication link to update critical stimulation parameters. They freak out a little bit, understandably. And it was the first time I realized that this notion of, I sort of took for granted the idea that we could rigorously authenticate, what is the thing I'm talking to, a remote device, identity, is it running the right software, is it correctly configured, and all these sorts of things. I just assumed those primitives existed. Hardware engineers, I think, have an assumption of, isn't that just software? And realized that none of this has been built. And so we came up with a solution for our own purposes, but I was looking at what to do next. Realized this was a really foundational problem in the internet, really. And we started Gradient to address this problem. How could we engineer trust into every communication? So coming at this from the outside, again, you don't see cybersecurity in my background anywhere. From a first principles approach, how would you look at this industry? What's really damning is, for the last decade or more, over 80% of all breaches take the same path. They're all credential-based attacks. And you have Verizon and IBM talking about 83% of all attacks are credential-based attacks. Wildly lower. They're wildly lower than reality, because everything really is in service of stealing credentials, right? Malware is trying to steal credentials. Phishing is trying to steal credentials. I can't think of an attack of relevance that didn't involve a credential-based attack. So if that's the common root in all of these things, why haven't we solved the problem? Not to diminish the work of the entire community for the last several decades, but it seems kind of obvious. And so we really started digging into that. And sort of I'm sure given this is a FIDO conference, there are people thinking, well, hold on, we've solved a lot of these problems. FIDO2 phishing-resistant authentication prevents all these attacks. Well, yeah, it's better than what we had before, no question. Credit should be given there. But actually, I'll skip there. So why are these problems here? Well, foundationally, we didn't design the internet with security in mind. I think everyone kind of knows that. But really, if you think about how things were built in the very beginning, everything has been credential-based, certificate-based authentication from the beginning. But in the beginning, we're talking about, maybe even in the 90s, we're talking about maybe 100 million devices on the internet. It's not crazy to think that issuing a credential, a long-lived credential to a device was a reasonable way to establish trust in that device. Users and devices sort of one-to-one mapping. We don't all have 10 devices at the time. And so, the TLS protocols or certificate-based authentication, we continue to use the same approaches since then. Nothing has really changed since, I would say, mid-90s. I actually had a chance to talk to Vint Cerf at a Hertz Foundation event recently and asked him about this. And he's quoted as saying, I didn't pay enough attention to security. Very, I think, underselling the point there. But talked about the need for a notion of continuous authentication and reevaluation of trust levels, which I was encouraged by. So the core issues that we've identified, again, I think are sort of obvious, are long-lived credentials are a problem. And I would say one of the limitations of passkeys, for example, is that passkeys are infinitely long-lived. We have generally weak binding of credentials to devices, and so device-bound passkeys do something there. But there's also, as I sort of get to here, the credentials we're talking about, there are multiple credentials, right, involved in authentication, and the one that really matters today is the session credential. And nothing today, no solution you can buy today, except for ours, solves that problem. And it's the single largest point of attack that's being targeted today. So starting to get a sense of where the problems are, what would a solution look like, I'll get to in a second. Again, this is where I was going before. So FIDO2's done a lot of great stuff. Phishing-resistant authenticators do a lot to solve some of the low-hanging fruit problems. But even with all of those things deployed, as we've seen in the last several years, more than half of the attack vectors that are available tools to an adversary still work. So I can still breach your infrastructure, even if you have every best practice FIDO2 phishing-resistant authentication tool everywhere. And there's a nice quote here from Okta's CSO 3 months ago, I think, saying, again, I think quite underselling it, attackers are now focusing on post-authentication attacks. So the Okta breach from November of 2023 was a session credential attack. You can they spin it a different way, but fundamentally the problem was an attacker was able to gain access to their infrastructure. That attacker was then able to exfiltrate these long-lived session credentials from the HAR files that are stored on their infrastructure, and with that could access every single Okta customer. And they still can, by the way. This problem hasn't actually been solved. Conveniently, we overlay with Okta, so if you deploy our solution on top of Okta, we prevent this. But clear problem that we need to address beyond phishing resistance. What does a solution look like? So our take is unique per device credentials that are ephemeral, and I really mean ephemeral. So if you look at how long it takes an attacker to exfiltrate and make use of a credential today, it's like 15 minutes. So Microsoft's own data suggests that, I think it was Lapsus is the one they were targeting. It took them 15 minutes to exfiltrate a credential and make use of it. We now know Lapsus is some kids in a dorm room, right? So if they can do it, who knows what a more advanced adversary can do. So we need to have very short-lived sessions, credential lifetimes. Our infrastructure, we've settled on about 10 minutes by default. We can go faster. SAML 2 can't go faster than that. Shared keys are a really bad idea. With all due respect to the sort of passkey standard, I know that synced passkeys were an approach to improve the user experience, but fundamentally, if I can break one of your devices, I can break all of them. and you don't know which one I broke, when it happened, this is a problem. So we have to have short-lived credentials. They have to be device specific. We've got a bunch of great infrastructure that already exists today. Almost every device that you have in your pocket right now, or on your lap, or whatever it is, has a hardware root of trust. So you have a TPM, you have a secure enclave, you have ARM's trust zone, and Android. Let's use those. So make use of those roots of trust to anchor device credentials so they're not easily exfiltrated. And not just the identity credentials, but also the session credentials. Again, that one becomes much more difficult because of how often they have to be used, but it's doable. We've done it. Another one, this actually came up in the White House memorandum on zero trust, if anyone read the thrilling letter. The OMB came out with a summary response of what are the things that we need to be doing to realize zero trust. One of those was evaluating device-level signals. I'd like to think we had something to do with that one. But by attestation, I mean a trusted third-party evaluation of the state of a device that's ideally cryptographically signed. So again, almost every root of trust, every device you have has a root of trust. That root of trust can attest to these device measurements. We do this continuously. Intel Attestation Service does this, Apple does it, they just don't do it very frequently. And again, no one wants to have another piece of hardware. I'm going to upset a couple vendors here, but really everyone we talk to hates having another piece of hardware, and you already have a bunch of hardware that does this stuff, so let's not add complexity. We can do this in software. Building this kind of solution took pulling together some really foundational experts. So we pulled together a team 6 years ago of, literally, so Srini down here invented the secure processor. Ed invented Wi-Fi. And Anna did some foundational stuff in cryptography, anonymous unlinkable protocols. So we picked their brains on how would you do this, given you guys built the primitives we're working with. And it wasn't cheap, wasn't fast. We spent about $15 million over 4 years to do it. 18 months ago, we came to market with an enterprise user and device authentication solution as our first application of this. We can't do this alone, looking for partners to work with us. But the end result is really cool on a couple of points. So one is the security value, which I've been really focusing on so far, but the other is user experience, and I can't undersell that point. So when we talk to prospective customers and trying to get them to adopt a new technology solution, the security value stuff, no one really cares. I wish they did, but the thing that people seem to really get excited about is the minimal user friction. So if I can avoid the need to continuously put in two-factor codes, even sort of tapping a dongle, for example, people don't like to do that. So there's this trade-off right now in existing solutions between I want really short-lived sessions, so 10 minutes is great. No one really does that outside of ours, but and even hour-long sessions, you actually get engineers revolting. I was talking to Kevin Mandia from Mandiant before I knew who he was about their response to a breach they had. They were trying to shorten their session lifetimes, and they tried to do hour-long. Everyone revolted. I think they settled on 4 hours, right? So right now we have this trade-off between usability and security, and we can resolve that issue by leveraging best practices biometric solutions. So the FIDO to phishing-resistant biometric authenticators that are ubiquitous today, our solution makes use of those to authenticate the user, and then we really focus on verifying the device itself and using a device as the foundational piece of identity. So that also sort of like flipping the current paradigm on its head. Instead of thinking about a user as the user is the identity, we are really all of our devices, right? So if I have identities bound to each of my devices, it's much easier and more tractable to verify that that's correct. And then verifying you or the person who's accessing the device is something we can do fairly straightforwardly with all of the great work that's been done with these FIDO2 authenticators. So first use cases that we're tackling, we're applying this technology to enterprise user and device authentication. So there's a bunch of regulatory burden coming out about, whether it's in finance or healthcare or otherwise, the need to have MFA everywhere. We found that the more senior an executive, the more averse they are to MFA. And so having a seamless user experience is something that's really been helping there. So we're starting there. We've talked a lot to a number of people here about what could that look like in terms of a B2C context. So if I'm, authenticating my large number of users to my service across multiple devices of their own, so we could bake this framework into the app on a mobile device or a workstation or an embedded system. Another piece, just to throw it out there, we're hearing a lot of things about using cybersecurity to using AI to enhance cybersecurity, but really shouldn't be worried about securing AI itself. So applying this to securing API interfaces and so forth. And finally, the lower level we get, the easier this is to do. So baking this stuff into embedded systems everywhere is actually, the closer we get to that, the easier this is to do. Something else we're working on. So progressively longer tails. But I guess to make this a sort of collaborative talk, we're pretty excited about the response we've been getting from this sort of credential-anchored, ephemeral, attestation-driven authentication solution. I think there's a lot of things here that are synergistic with Passkeys, for example. So we work with Passkeys on Apple devices in particular, but really anywhere. And I think what we can do here is achieve the goals that sort of the Passkeys have for consumer-facing in the more rigorous and difficult to satisfy enterprise constraints. So enterprise environments have the additional requirement that I need to be able to centrally manage all my users, their devices, and access to user, device, and services level at those granularities. So if we need to fire Chris for corporate espionage, we got to remove all of his devices. That one's pretty easy. But what if he leaves his phone in Starbucks in Moscow? Like, separating that one out specifically is a little harder to do with the passkey infrastructure as it is now. We actually act as a layer on top of the passkey, so you need both the passkey and our authentication credential. I think that may be a path forward for these kinds of things. But really, you want a single pane of control to instead of having to go to multiple different layers to address the problem. So we've got some time left over. I will stop there, and thanks for your time. Any questions?
I have one question.
Sure.
You mentioned that you're using passkeys with other authentication factors and signals. What kind of signals do you use alongside it? Is it proof of possession? Is it, or like what are you trying to what additional kind of factors, I guess, security are you trying to communicate to these relying parties as well?
Yeah. So we attest to, depends on what it is we're deploying to, but for, take like a Windows or a Linux machine with the TPM, and so Microsoft has done us a favor in forcing everyone to have TPMs for Windows 11. They were pretty ubiquitous before that, but a TPM we can use to attest to the system level measurements from first instruction all the way up through kernel package manager, operating system. We can actually use, there's a whole set of dynamic roots of trust that we can configure, so we can actually verify the integrity of things like, even things like container level measurements. So verifying the measurements of the software that you're running and the lower level firmware that you're running from a known trusted position, I think that's really key. So something we get when we talk to some audiences is, well, I have CrowdStrike, don't they do that? No. CrowdStrike runs a couple of million lines of code after us. And by the time they're running, any EDR solution is easily fooled because you can basically, every malware that we've seen over the last decade can hide its tracks before the EDR takes hold. So measuring at that low level, it's basically infeasible for them to hide themselves. So all those system level measurements, and then we're interested in working with partners on other data. Like I think it would make a lot of sense to work with EDRs, for example.
Any other questions? Oh, here, perfect.
I tried to ask through this. So deployment and adoption seem to be challenges. I mean, I've heard around the conference that any type of change is always difficult.
Yeah.
How do you approach trying to simplify the process of switching from whatever the existing form of authentication is to getting broad scale adoption to something new?
Yeah, good question. So yeah, people don't really love change, turns out. I thought that an FDA-regulated environment was hard. This isn't that much easier. It's just different problems. So we've really focused on trying to make it as easy as possible to deploy. So we interface with, Okta, Ping, Azure, one login. I'm missing some, I'm sure. But using things like within Okta, for example, selective routing rules, so that you can try this out on one device or 10 devices at a time instead of having to switch over the entire organization. So making it easy to deploy. You can deploy our solution within 30 minutes to an enterprise scale organization. Making use of things like MDM to deploy this. There's a very lightweight app. I didn't really talk about this at all, but we do have a very small piece of software that we deploy to the endpoint. Its only purpose, really, slightly simplifying, is to communicate between the root of trust of your device and our backend infrastructure. So it's so lightweight that on a Mac, for example, it doesn't show up in the active process list. So we use whatever mechanism you've already got to deploy that. Jamf for Macs, but really anything, or we can even, if it's a very tightly managed infrastructure, we can bake it into the system image.
I got one more, since we got time. So, I mean, you talked about passkeys and kind of using ephemeral credentials, but have you thought about how I guess authentication with the system could work with something more durable, like digital credentials, verifiable credentials, and I guess more digital representations of physical cards in the system. And as sort of like authentication moves in that direction, do you think longer-lived credentials will be more common?
I mean, I think so. When I say longer-lived credentials are bad, I feel like IETF would agree with me on that one, but you need a persistent notion of identity of a device, right? Like that, and there's that trade-off. So I'm simplifying a little bit in how I talk about what we do. We actually do have multiple different credentials. We have one that's very long-lived. It's just that we want to see the long-lived one that persists across the lifetime of the device. So if you buy a TPM from Infineon, they're great. We like them, even though that little elliptic curve issue with YubiKeys, everyone has their issues. So those ship with the manufacturer certificate that has, I think, a 10-year lifetime or longer. And it's a reasonable thing to assume that credential can be that long-lived because it's hardware protected. So the higher up in the stack we get, the more accessible the credential, the more short-lived it should be. That's kind of our approach. So you can have long-lived credentials. We just want to have something on top of that as well that says, okay, and we've also evaluated, like, this is still relevant.
Thank you. Sure. Any other questions in the room? Perfect. Oh, yeah, please use the microphone.
So your solution is focused on measuring the device posture and not necessarily the understanding the user that's trying to authenticate?
So at the moment, what we found in talking with prospective customers early on was almost everyone had if they were using biometrics, they had a biometric solution that they liked. So our position was to say, let's not make you use our user authenticator. We have one. We could deploy it at scale, but we typically, so we work with like Windows Hello, Touch ID and Macs, whatever it is you're using today for a biometric authenticator, but again, it doesn't have to be biometric. We'll make use of that.
Okay, thank you.
Right on. Well, thank you very much, Christian, for your time.
Thank you.
One more round of applause.